forces in equilibrium. Take for instance, a ball that is hung against a wall, for instance. Hung against, let's say, this is a wall, this is the ball, and the string from the ball that holds the ball to the wall. This ball, this is the diameter of the ball. At the center here, the weight, this is the weight of the ball. This is the weight of the ball. Now, this we can get the tension on this rope, that is this AB, on rope AB that is holding the ball. We can also get the reaction of the wall, the reaction from the wall, the reaction from the, as the ball is hitting the wall, the reaction, that is BC, the tension BA, if we know the weight of the wall. If we know this, now let us see how we may do this. Here, this is the weight of the wall, the weight of the ball. Now if we produce this, we will see that here, this angle is 90 degrees. That means this is also 90. And because of the fact that this is a diameter, a radius of the wall, and this is a radius, that means this angle, this triangle, this is the triangle ABCD will be an isosceles triangle, which means a right angle isosceles triangle, which means these two angles, angle DBC and DCB, will all be 45 degrees. 45 degrees. So here the same thing, 45 degrees. Now, if that is the case, if this is also 45 degrees, that means the angle here, this is 45, this is 90, this is 90. That means total of this is 180. And the angle at the circumference of a circle is equal to the half of the one at the center of the circle. So in this triangle, that means this angle, this is E. EBC is equal to half of EDC, that is the angle in a straight line. So that means this angle will be 90 degrees. The whole of this, that's 45, 45, that's 90 degrees. And this is the angle in a straight line, EBA. And that means this one is also 90 degrees. And if this is 90 degrees, this carries the tension in the rope. If this is 90 degrees, and this, if I now have to bring it out, if I bring them out, this is the weight. This will reflect the weight of the ball. So if I have the weight of the ball vertical, I have the tension in the string inclined, that is from B to C. I then have the BC, that is the reaction from the wall, BC. So if I want to show that they are in equilibrium, if I want to enclose them in a triangle, I will have the weight of the wall, the weight of the ball, then the reaction from the wall, then which closes with the reaction from the wall. That forms this triangle. That means this is B, this is C, or if it's C, okay. This is, let's say, E here. That means line CE, which represents the reaction from the wall over sine 90, is equal to CB, which represents the string, which represents the tension in the string, over sine 45, which is still equal to AB, that's BE, which is the weight of the over sine 45. So with this, I have the weight of the ball, sine over sine 45, is equal to CE. So for me to get CE, CE will be equal to CE, that is the reaction. The reaction from the wall, reaction of the ball from the wall, that will be CE is equal to BE, which is the weight of the ball, sine 90 over sine 45. Sine 90 is 1. So, for instance, let's say that the weight of the ball, let's say that the weight of the ball is 20 newtons. The weight of the ball is 20 newtons, for instance. 20 newtons. The length of the string, from the wall is, let's say it's 4 meters. This angle is 45 degrees. So with this, and if this is 45, the length is that. So it's simple. I now have, this is 20, this is equal to 20 sine 90. Sine 90 is 1 over sine 45. That is CE, which is CE, which is the reaction from the wall. The reaction from the wall. The reaction from the wall, which is equal to is equal to 14.114 newtons. 14.14 newtons. It happened to be the same thing with BE. Then CB is still equal to, that is 20 sine 90 over sine 45, which is something, which is still equal to 14.14 newtons. So we can easily get the reaction if a ball is hung against a wall with a string. There is tension in the string, there's the weight of the ball. There's also a reaction from the wall. The wall will react because the ball is hitting the wall. So now if we need to get, because we know the weight of the ball, if we're now supposed to get the reaction in this, the tension in the string and the reaction from the wall, is to arrange the three of them: the weight of the ball, the reaction from the wall, and the tension in the string. We arrange them so that they close. The weight of the wall is vertically down. The weight of the wall is vertically down. Is vertically down. The weight of the wall is vertically down. Then the reaction from the wall is up, and the string, the tension in the string So it closes. This angle is 90 degrees. So CB, CE, and BE. Then this is the weight of the ball is BE. The angle is BE. The reaction from the wall is CE, while the string, the tension in the string is CB. So it's simple, just like we have here. The weight of the wall, 20 over sine 90, because this angle is 90. That's BE over sine 90 is equal to CB, which is the tension in the string, over sine 45, which is also equal to CE, which is the reaction from the wall, over sine 45. Simple. So to get CB, which is the tension in the string, is simple. Cross multiply. We have 20 sine 45 over sine 90. No, yeah. 20 sine 45 over sine 90. So CE is equal to this 20 sine 45 over sine 90. So each of them gave 14.14 newtons each. It's as simple as that. If a ball is hung. So that's the end of this, being able to get the reactions.